Okay, so yeah, let's move on to our next talk, and it's Jason Kneen. He's coming from England, yeah, near London, in the south of London, I guess, somewhere.
Southwest, yeah.
Southwest, okay. And he's a freelancer, so he's programming or developing with Accelerator, Titanium SDK. And he has a lot of experience, and I guess, yeah, he will share something of his experience in his talk now. So, yeah.
So basically I'm freelance. I've been freelancing since, 2013, but I've been developing with Titanium and Accelerator since 2010. So in the 90s I was doing apps for mobile organizers, sign organizers and things like that, went into web development and then got into app development, and that's basically what I do full-time, work for clients in the UK and the US and all over the world. So the topic of the talk is native apps with JavaScript and covering Titanium. And the first question is, what is a native app? What constitutes a native app? And different people have different definitions. So if you look around on the web or you do some research, some people say that a native app is an app that runs on a smartphone and it's developed with the native SDK. So it's written in Objective-C or Swift or Java, and that's what a native app is. That's typically what most of my clients think when they email me and say they need an app. I need an app done in Objective-C or Java, because that's what they perceive to be native. Another definition is an app that runs on a device. So you download it from the App Store, you install it on the device, it's a native app. Of course, hybrid apps come into that category, but again, that's a perception that some people have. And the other one which I like to use and is more common in terms of JavaScript native apps is a native UI. So you might be running code on the device that's being interpreted, or there's a runtime, but your UI, your actual buttons, your labels, your windows, your views are all native elements. And in most cases, and with some good code and optimization, the user can't tell the difference. When it comes to things like gaming and high performance stuff like that's a different story. But for most typical apps that people want and people come to me for, you can write something in this with JavaScript using a native UI, and they can't tell the difference. They just think it's native. So building native apps, well, traditionally you had to go through the standard SDKs. When I first started looking at it in 2010, it was Objective-C. Downloaded Xcode, trying to go through Objective-C to put an app together, and realized I didn't have a clue what I was doing. That's when I got into Titanium, because I knew some JavaScript and realized that I could put something together much quicker that ran natively, seemed to run natively, but I could get an app running and put it in the App Store within a day. If you're on Android, then obviously developing in Java and Windows, C# with the Windows mobile platform using Visual Studio. And there are other things out there as well. You can use RubyMotion, you can use other tools to write native applications as well, but that was traditionally the way of doing it. And obviously that's fine if you want to build a single app, but typically clients or businesses want multiple apps, multiple platform support. So that means you've got to have multiple developers, or you've got to have a developer that is skilled in multiple platforms. And that's going to take time and it's going to cost money. You could put 5 developers on a project or 3 developers on a project for 3 platforms and get it done potentially in the same amount of time, but it's going to cost more. And it's still more people time in terms of developers. So this tends to obviously increase the cost of development, but not only increase the cost of development, once the app is developed and in the App Store and you finally made it, you've got maintenance issues. You want to change something in the business logic of the app, you've got to do that several times. And it might be something that's got nothing to do with the user interface. It's something to do with the way it interacts with an API. You've got to do that 3 times or multiple times, and that costs more, and it's higher maintenance, and there's the potential of bugs creeping into different platforms. And all of this drives a platform-first attitude. So I get a lot of customers and clients that come to me and say they need an app, and they want to launch it on iOS first, because they just want to get that out there, see if it works, see if it takes off, see if they make money, and then they can actually go onto the other platforms. So, does cross-platform come to the rescue? Why cross-platform? Well, firstly, you're typically coding in a single language. In this case, I'm talking about JavaScript, and we're talking about JavaScript today. But there are other products out there like RubyMotion that do this sort of thing. And obviously, Xamarin does C#. But you're normally coding in a single language across those different platforms. Ideally, you can achieve a single code base. Rather than having all these separate repos that you've got to maintain, you can have one code base that can deploy to all those different platforms. You can benefit from a cross-platform UI. So cross-platform frameworks typically abstract the underlying SDKs to give you an interface that's common on all those platforms. So you can write one piece of code to create a button, and it's going to work on all 3 platforms, or 2 platforms, whatever you're doing it for. And the end result of all this is that you can get to the App Store or the Play Store quicker and cheaper, because it's much easier to deploy from a cross-platform app, especially if it's got single code base, and especially if you can get a code share of, say, 95%. So the options for cross-platform currently are obviously mobile web. It's not native, but it's a website. It's a responsive website that runs on different browsers and obviously runs on different devices and screen sizes, and it's the easiest way to get out there and get on every device and make sure it works on desktop and everything. But anyone that's used mobile web apps knows that it's rare to find some that are well optimized and well written. They usually break, they're usually slow, they're unresponsive. They're still a website, they're still running remotely. If you want to add that website or that app to your desktop, you've got to create a shortcut or do it in Safari or whatever you're using on Android, and you're still reliant on the browser to run all that. It's not running in a perceived native way on the device. The second option is hybrid. So hybrid is a wrapped mobile app. It's a local version of that app running on the device. It has a native wrapper. You can have hybrid apps that have quite a few native components and then use, small parts of them are hybrid in terms of web-based. And the App Store is a good example. It's a hybrid app. If you've ever loaded the App Store when it's slow and all the buttons break and you see the CSS doesn't load or whatever, it's a hybrid app. And there are apps on iOS and Android that do the same thing. So it depends how you want to do hybrid. I mean, some people will do the entire app as a hybrid app and then just put a wrap around it. And that gets them in the App Store. It gets them interfaces to the camera and to other things that they might want to use on the device, accelerometers, things, other things that they might need access through, or Apple Pay or things like that, Touch ID. And some use hybrid as a sort of complement to their app. So they might have an app that's got many native elements, like the App Store. It's got a tab group that's native, and it's got some dialogues that are native. But then it's using hybrid to lay out some of the screens. And the final option is a fully native UI, which is when we're actually creating native elements, putting them on the screen. It's a native tab group, it's a native button. Everything is running on screen natively. There's some code running behind the scenes that might be using a runtime, like a Java runtime or JavaScript runtime, but the interface is all native. And the animations that you're getting are native. When that navigator slides in a screen on iOS, it's a native animation. You're not doing that yourself. So you get good performance and it feels like a native app. There are several solutions. I'm covering one mainly, but I'm talking about 3 briefly. NativeScript, React Native, and Titanium are all JavaScript based. They all use, and I'm generalizing this a little bit, but they all use a similar process in terms of how they work, but some work slightly differently and some majorly differently than others. But essentially, what they're doing is taking JavaScript code that you're writing. There's a magic bit in the middle, which we refer to as the bridge, pretty much in all these platforms. And the bridge is taking care of creating the relevant native components on the native side. So the over-the-bridge calls that I might talk about later on is where I'm creating a button in JavaScript. I get a button object in JavaScript. What it's doing on the other side of the bridge on iOS is it's creating a UI button. And on Android, it's creating a button, an Android button. When I change the properties of that button, it's translating that across the bridge to the other side. And there are performance things that you have to be aware of with all this. But essentially, that's what it's doing, and that's what all these platforms do. Now, what some of them do is give you a direct access to the underlying SDK from JavaScript. So you're coding for each platform using JavaScript. So your JavaScript code is an Android JavaScript, or it's iOS JavaScript. What some of them do, like NativeScript and Titanium, is they create this abstraction layer, which you can use to do your cross-platform stuff. So you create a button, it's a button on both. You create a label, it's a label on both. It's exactly the same code. It's identical, and you'll see the example that I'll show soon that shows almost exactly the same code. There's a couple of conditions for Android, but it's identical because it's using the cross-platform API. So NativeScript's a bit like that. It's got the cross-platform element, but you can also delve down if you need to. And one of the common challenges that you can get with some of these frameworks, especially when you have the cross-platform approach, is sometimes you want to target a specific feature of a platform. You want to go into a specific feature of Android, a specific feature of iOS, and it's not supported in the raw Titanium, for example, cross-platform API. So you have to write native modules or native code to access that. So Titanium works using that principle, You create a button, you have a JavaScript layer, you create a button in JavaScript. It goes into the Crossplatform API, the ti.api or ti.ue namespace to create the button. The button's created, the Cross-Platform API creates the relevant objects on the other side, so UE button or Android button, and takes care of the translation of properties and methods and events across that. There are situations, especially with Titanium, there's a solution which is the bottom point in this list, where you do need to access these underlying SDK properties or features, or there's a third-party SDK that you need access to, and Titanium is not going to have that in its Cross-Platform API. And that's where the native modules comes in. That's where you need to start writing native code, which traditionally means Objective-C or Java to start writing those modules for support. You expose the properties to JavaScript, and then you can use them, drop them in the project, and use them normally. Now, what Titanium has added recently, or Accelerator have added recently, is something called Hyperloop. And Hyperloop is a new module that you can add into a project and basically gives you direct access to all the underlying SDK. So you get access to everything in Android, everything in iOS, even the beta downloads that you might download where the stuff isn't published yet. You get access to all of that without anything from Accelerator in terms of an update. No need to wait for the Titanium API to be updated. You can just go straight in and do what you want. And you write all the code in JavaScript. I'll cover it a bit more in a second. But the nice thing about that as well is that you can drop Swift classes in. You can drop an Objective-C class in or a Java class straight into your JavaScript project and access it just like it's JavaScript. Just require it and use it. So the end result of all this is you end up with a cross-platform native UE. It's coded in JavaScript. It's native UE across all the platforms. I'm sharing code, libraries. You can use Moment.js. You can use all the JavaScript libraries that are out there. You can install some from NPM, some modules and use those. So you've got access to all of that resource to be able to write code. It's a native experience for the users. So as far as the user is concerned, it feels like a native app. And if it's optimized and the performance is right, they can't tell the difference. And typically, with my code that I'm doing and my apps that I'm doing, I'm getting 90 to 95% code sharing. So pretty much iOS, you can develop the app in iOS. And if I've spent a month developing an app in iOS, I can probably get it on Android in a couple of days, if that, maybe less. Because typically, your back-end code is the same. Your API interfaces are the same. Your business logic is the same. It's usually the fact that you're using a tab group and you want to use something else on Android, or there's a layout issue or coloring issue or font issue or something like that. And it's usually visual tweaks that you have to worry about. So why Titanium? I've been using it, like I say, for 6 years. Firstly, it's free, it's open source. The Titanium SDK is open source, it's always going to be. It's fairly established, being 6 years old. It's gone through lots of iterations, lots of upgrades and changes. It's on 5.5 at the moment. They've just added support for, the iOS 10 came out on the same day for support for iOS 10, and version 6 comes up soon, in November, I think. It's part of the Accelerator platform, which is a paid platform. I think it starts at about $39 a month for the indie plan. And that adds a load more features. You get the Accelerator IDE, you get more debugging options, you get a back-end API builder called Arrow and analytics and many more features. But the raw Titanium SDK that you can code with is all free and open source. It runs on iOS, Android, and Windows, although I get pretty much no Windows inquiries. It's all iOS and Android. And you can usually put them off by just putting the price up for Windows anyway. But it will do all three. Hyperloop comes with the Accelerator platform. So if you've got a Pro license, you get the Hyperloop component as well. So that's an add-on. And that's awesome. I mean, there's a sample of code on the next screen that shows what Hyperloop code looks like. And it just changes the way that you work natively now and access these native modules and SDKs. And it also comes with the Alloy framework, Alloy MVC framework, which traditionally in Titanium you coded in JavaScript, but you literally made everything in JavaScript. You created a button, you added the button to a view, created the view, added the button to the view, added the button to the window, put your event listers in. It was all JavaScript code. And I'd probably kill myself now if I still had to write like that. Because it's just a nightmare looking through code and understanding how things relate to each other because people can put the blocks of code in different places. What Alloy MVC does is make that more structured, and I'll cover that in a second, and it just makes building apps much quicker. And you'll see from the sample code that I've got, which is a simple little to-do app, that there's virtually nothing in there in terms of code, and yet it's a to-do app that you can add tasks and complete them and save the data locally. So here's an example of Hyperloop code. So like I said, that's just creating a button and adding a button to a screen and doing a click on it. So it's a little bit of code you have to write, but it's the nature of iOS that you have to define everything in these ways. But you can sort of see, if you're familiar with Swift, you can sort of see what's going on in terms of what's being required in and how the button's being created and how it's being styled and everything else. And, you know, behind the scenes, in the cross-platform layer of Titanium, that's what's happening. It's this sort of thing that's happening in the background. It's just that in Titanium, that's literally three or four lines of code, because it's doing all this in the background for you. But if you want to, you can delve into this and do it all yourself. And you can even create alloy tags for XML views that define all that. So you can have a UI button that you can just drop straight into a view and it will render it for you. It works alongside Titanium. You can drop in Swift classes, Objective-C classes, mix and match as you need to. You might need access to I've seen examples where someone needed access to a specific control in Swift. Just drop that class straight into the project, required it via JavaScript, and then just used it and plopped it straight onto a Titanium view. They're all interchangeable. Alloy MVC pretty much changes the way that you end up building Titanium apps. So it's based on models, views, model view controller. It's got models and collections. It uses Backbone, but you can pretty much plug in anything you want if you wanted to. It has XML-based views and TSS, which sounds like CSS, but it's not. It's similar, but it's basically abstracting the properties out into a separate file so that you can just have all that separate from the XML itself. JavaScript controllers are interfacing with the views and can interface then with back-end CommonJS libraries if you want to do share the code or have business logic like that and just have the controllers putting stuff into the views. You can also do platform-specific code. So this is one of the cool features of Alloy. Traditionally in Titanium, whatever if you wrote some code for Android or iOS and you were checking whether the platform was iOS or Android and then you built that app, it contained all the code. So all of your iOS code was in an Android app. It was just conditioned off, but it was still sitting there. And that's not a huge amount of space it's taking up, but it's still sitting there. With Alloy, what happens is if you use any of the conditional code elements, so if you say, if this is iOS, do this, that's removed when it compiles it and builds it. So that's taken out, it's pre-processed, and it doesn't go into the app. Same with the assets, so any images. I saw examples like before in the traditional Titanium code where Retina images were being put in the generic images folder for both platforms. And so Retina images were being packaged with Android apps when they were never being used. So an Android app was 25 meg when it could be 12 meg because it had all these Retina images in there. So separating out all of this stuff into separate folders means it's only going to be targeting that platform. And you can choose as well how you split your code. So a few platforms like React Native, it starts with an index iOS and an index Android. You're sort of split from the start. With Titanium, you can have single files that contain conditional code elements in them, so it's just one file for both platforms. You can have separate files in separate folders. You can choose how you want to split that and how you want to deal with it. So if you have two views that are vastly different in iOS and Android, and you're trying to combine them in the same thing, you can just have two separate files with the same name in subfolders, and each one will get called to the relevant platform. And both those views could still go back to the same controller. It's also got widgets and reusable modules, so there's a whole library of widgets you can download, which are literally mini Alloy apps, and they can just be dropped into a project and used like calendars and things like that other people have written. And the models and collections side, you can plug that straight into APIs. There's a really flexible way of connecting to pretty much any RESTful API. There's also modules. There's a module that I've written that will connect to pretty much any API, whether it's RESTful or not, and give you full CRUD support with your models and collections. So you get really, really nice data binding. So on the next screen, we've got an example of that. If it comes up. There we go. So there's an example view. So we're using XML layout, and you can see instantly the structure. You can see we've got a navigation window. This is an iOS-specific piece of code, but we've got the module attribute, which I'll explain in a second. So navigation window, it's iOS. We've got a window. We've got a class container, which relates to a class in the TSS file above. It's got a title, it's got a view inside, and you can see immediately, it's like HTML, you see the immediate relationship between everything. There's no confusion as to where the table is. But if you look at things like the table view, we've got a table view and a table view row, and then data collection, and that's one of our collections. So that's one of the data collections that basically gets bound automatically. So there's no, in the old style Titanium, you'd create the table view row, you'd create the label, you'd add the label into the table view row, you'd add the image, you'd add that to the an array, and then give that to the table view. You'd write all this code. With this, you create your template row, you drop in the collection name, you do a fetch or a change event, and bang, it renders the entire thing. And if you change any of those models, it changes it instantly in the table view. There's no rebinding. It rebinds for you. So you're not having to do any of that manually. It uses CommonJS, so you can have CommonJS libraries. You can download libraries that already exist, drop them in the lib folder, and just require them and use them. So here's an example of the platform-specific stuff. I tried to sort of capture a screen that got a couple of folders. So you can see we've got assets. Underneath assets, you'd normally have images. So images can be your generic images. They'll be on every platform. That's typically what I might do to get started, to get an app going while I'm waiting for graphics from designers who don't really understand retina imagery and things. And then platform-specific folders underneath. So the iPhone, it's only going to load that for iPhone or iOS. Android, it's only going to load those for Android. So you can separate everything out nicely, have different splash screens, have different icons, have different assets completely for all the different platforms. You can also do conditions in the TSS. So I probably took that screenshot badly, but task name was already defined above. So there was a generic definition for task name setting the colors, the size, the widths, and everything else, which is the field. It's the text field on the form. And then I've just done an override for Android where I need to change the hint text color, because it wasn't coming out in the right color on Android, but it was fine on iOS. So you can do those little overrides. You can even put custom code in as JS, which you can then call to do special conditions. And you can do based on form factor, is it a phone or a tablet. So your one view will change based on being an iPad or an iOS or a tablet, an Android tablet. You can even do stuff, there's a widget you can download that will work out landscape and portrait. So as you rotate, you could have a completely different view. Everything can move and change. So it's really, really flexible. Now the challenge with cross-platform, obviously, is the perception is that if you try and do something that works on all these different platforms, you're going to end up with a substandard app. It's the lowest common denominator. There's also confusion about the standards between these different platforms and different devices. So this was a tweet I saw a while ago saying about type being the only constant, but there are several other constants, 4 specifically on every device, and that's top, left, right, and bottom. And knowing things like that when you're developing cross-platform helps, because using percentages, using fluid layouts, using those known positions means you can define something, a button that's going to be indented on both sides of a screen, depending on what size, relevant of what size screen it is. Where you get into trouble is when people start putting things in pixels instead of density pixels, or not doing fluid layouts, and all of a sudden you've got a 6S Plus or whatever, or a iPhone 7 Plus, and all your buttons are over to the left, all your interface is over because you've fixed everything. So just using simple things like that makes a big difference. The other challenge is customers. So what I tend to find is I have to push back a lot with clients, because you get situations like this. People who want tab groups with tabs at the bottom on Android. There are controls coming that can do this, but typically tabs are at the bottom in iOS and at the top in Android. And you'll get a designer that says, no, we want the tabs at the bottom. That's what's been signed off. That's what we need. And what ends up happening with a lot of developers is they say, okay, they do it, and they end up creating a tab group. They create the views, they create the icons, they create the image views, and what they're doing is creating native UI components still in Titanium, but they're not using all that built-in capability that's already there, that's in iOS and Android. So I've seen example apps where, it's one of the apps I showed earlier actually, the first version of the MBPA apps, which I inherited, were sort of classic apps. They hadn't been done in Alloy. They'd manually done a tab group in both platforms, so not even iOS. They were using a completely made up tab group, and when you clicked on an item to view it, they were sliding it in themselves with their own animation. And I think they actually did it the wrong way. They slid it from the left instead of the right. So it was terrible, because they were doing that animation themselves. It was still a native window coming in, or a native view, but it was JavaScript code that was doing it, which is insane. The JavaScript code was changing the position of that window. So there was an over-the-bridge call every single time it was trying to change the pixel position. So we just stripped all that out, wrote a custom tab group, put the native tab group in, and Titanium's tab group defaults to an iOS tab group on iOS, but exactly the same XML uses action bar with all the tabs at the top on Android. So it's native on both platforms. Using click to open on Android, so you click and it just comes in as a new window, just like normal Android apps, and using slide in of the standard open window command in iOS. Native animations, perfect animations, nice and fast, completely changed the app, and it felt much faster, much more native, because it was. So these are parts of the challenges. Single code-based thing sounds nice. But it can be a challenge. You can break stuff. I've done it many times. So you're stuck in iOS, you're working in iOS, you've got an iOS app working, You fire it up in Android, you realize the labels are the wrong color, the table rows are too narrow, everything's gray or whatever. You tweak all these colors, you tweak everything, but you forget to put your conditional statements in, you go back to iOS and everything's broken again. So it's great, but you have to be careful. You have to know when to separate the code out. You have to know when, if you're writing too many conditions in a huge block of JavaScript or too many conditions in XML, you probably need separate views. You probably need to just break those out and have Android and iOS specific. Using the UX and UE standards of the platform. So, pushing back with clients to say, you need to use these native components. And many of the problems I see when I see people who've used Titanium in the past and have said, it's slow and it's doing this and it's not performing very well, is when you look at the code, they're doing a lot of this stuff manually. They're not using the native components, or they're trying to do, I know pull to refresh has sort of come to Android, but it wasn't on Android originally, and so they were doing all that manually, and they were doing little icons that spin around and flip over, and all of that stuff was not very performant on Android at the time, and so they weren't using a refresh button or a refresh icon at the top right, like many Android apps were doing. Or they weren't using the back button. So people were pressing the back button on their Android apps and it wasn't working because they had a back button at the top left, like Android, like iOS. So it's trying to stick to using those standards to get much better performance. Understanding device behavior and platform features. So the back button's a good example. Loads and loads of apps I've seen where you press the back button, nothing happens, and that's what Android users expect. They expect that to work. Asset densities, that's, nightmare. There are ways to make that easier. One of the tricks I use to start with is taking density, retina images on iOS, so at 2x images, and run them through a script that converts them to density images for Android. So it takes the 2x and turns it into a XXX DPI. Now it's not perfect, that's pretty much one-to-one, but obviously everything else is scaled, but it's a good start. And it generates you a load of images that will work on Android, but you can then give to a designer to say, I need replacements for all those, and let them worry about it. And then get back all the correct sizes. Testing is a challenge, obviously. With 6,000, I don't know what the number is now, but it used to be 6,000 plus devices that can run Android. And now with iOS, we've still got, the iPhone 5 is still there as the iPhone SE. You've got the 6, you've got the 6S, you've got the 7, and the plus sizes. So, it's not as bad as Android, but there's a challenge there with making sure that you test on these different devices. The simulators and all can help, but sometimes you need a device to actually run this stuff on. And performance, understanding that this stuff is running through a bridge. This is JavaScript, and it's usually running in a runtime on the device. And so every time you cross that bridge, you are taking a hit, which could be milliseconds, it could be microseconds, it could be almost nothing. But if you imagine, a table view where you're iterating through it and doing things to it, that's all happening across the bridge. So performance can be an issue, and many times I've seen cross-platform apps where the performance is bad because these optimizations aren't being done. So the way I typically approach things is making sure that I understand the requirements. So I've seen examples of people that have jumped into apps with a client, they've thrown a load of native modules in that they found on the web that are available. The client wants to do this, they want to do image filtering, let's throw this native module in. They've put all these things together, assuming it's all going to work. There's been issues, and then they've hit a roadblock. Maybe the native module doesn't support cloud picking from the image library from the iCloud. So all of a sudden, all of the images are coming up blank because it can't fetch it from the cloud. It's not been supported. So then they get into real trouble. Then they start blaming the platform because they can't do the things they want to do. So one of the things I do is make sure I can do the app. So when I get a brief through, it's like, can I do this? Is there something in here that's going to require a native module? Am I going to need to write it? Am I going to need to get someone else to write it? And how that, how that affects the costs. Sticking to the designing for the platform, sticking to the UE standards. It's just it's a no-brainer really. Unless you really have to go off-piste and start doing custom stuff, try and stick to using all of the native components that are there that you've got access to, because you're going to get the benefit of that in terms of speed. Performance, so I mentioned this earlier, so a good example is a table view. So in Titanium there's a table view and a list view, and they work quite differently. So with a table view, in an old style Titanium, you would create a table view, that's a bridge call to create the table view object. You'd then have a for loop or whatever loop you're using to create all the rows of data. So you'd create, let's say, 100 rows. So 100 rows would create 100 bridge calls to do the table view rows. If you had an image and a label, then each row requires 4 bridge calls because you're creating the objects, and you're adding them to the table view. You're then putting all that in an array and adding it to the table view itself. And you could end up with 600 plus calls over the bridge. And you've got, that's 100 rows. So imagine 2,000 rows. Now, ideally, you should be showing a certain number of rows and using optimizations to make sure you're only ever showing a few rows that are being seen and everything else is being loaded as it needs. But that's a big performance issue. It's too many bridge calls. So list view works by taking all of your data, a defined template that you create in XML, just like a table view, but you pass that to the native side. You give that over the bridge one call to the native side, and the native side binds it and renders it, and you get a perfectly rendered table view. You can scroll through. It's super performant on Android and iOS. Still many developers doing Titanium apps who have got lots of table view rows are doing table views, and then wondering why it's slow on Android or wondering why it's jumpy when they're scrolling. You've got to use the right thing for the right job. There's perfectly good cases to use a table view when you've got a preferences list or something. It's a bit over the top to use a list view. And if you want to do certain things that list views can't do, you need to use a table view. But there are optimizations that can be done. The other thing is targeting specific platforms. I make sure I say 4.4 and above for Android, iOS 7 and above, and I'm starting to say iOS 8 and above. It just makes your life much easier, especially like the iOS 6 to iOS 7 break was a big one. Obviously visually, and iOS 7 to 8 had some permission issues with push notifications and things like that. So trying to keep to a standard delivery makes it much easier to support later on. You don't want someone coming in and saying, I've got this cheap knockoff Android phone that I got off Amazon and it's not rendering correctly, and you have to spend time fixing it for that one thing, that one device. So let's look at some code. I'm going to show you some real code, which is a little concerning. If we can get rid of all this stuff, I don't need the Wi-Fi. So here's an example. This is an example I knocked up yesterday. It's a simple little to-do app. We've got, just to show you some of the structure.
Are you seeing something?
Oh, that's not very good. This is going to be interesting. I've got to do this at a distance. Okay. Yeah. You see that? Yeah? Yeah, this is going to be, okay, that's fine. Yeah, thanks. This is going to be fun. So basically we've got three things. We've got three things here. We've got our JavaScript code on the left. This is a plugin for Atom, so I'm using Atom. They've got some good Titanium plugins that do the split views on Alloy. So when you load a controller, you get all the other things coming up as well. So here's our view. We've got navigation window. We've got the window, it's the one you saw earlier. We've got a click handler in there on click, so everything is being done in the XML. And then in the styling, we've defined things like the window, the label, there's the task name, and there's the override for Android. And that's all that all gets pre-processed and put together. This isn't interpreted at runtime, this is all done beforehand, so it all generates basically JavaScript at the end of the day. And then in the, we've got our Alloy file here. This is like your startup file almost, it's like your sort of global file. So with this, I'm using a little library I wrote that just generates collections and models using Backbone more easily. So it's just a sample to say, here's some data, here's an array of data of two items, one's completed, one's not. So I'm just creating that task collection. And then in the table view, I've assigned that into the data collection there. So that's gonna, if I just fire up the simulator. So that's gonna build this, probably come up with a few weird errors. And there's a live view option. There's a couple of options that you can do with Titanium with hot reloads. So you can use live view if you're using Accelerator, and that will just reboot the app instantly with the changes you've made. There's also an open source. It's just loading on the other screen. There's also an open source tool called TI Shadow. I've gone the wrong way. Which does hot reloading as well. So as soon as you change a file, it reloads the app, which is quite nice for just tweaking styling and things. So that's our simple to-do app. I can tick boxes and it changes the list. I can add a new item and it adds it to the list. And this is all being done, the binding is being done for me. I'm not having to worry about this. All I'm doing in my index.js file, which I'll just expand a bit so you can see, is we're doing a trigger which triggers the binding. So that collection I created at the start, that's going to bind that to that table. Here's my row handler, so when I click on the table, it gives me the index of the row that I clicked, and I can just set that model to completed. And because I'm using the completed variable in the view, as the has check property, then it just immediately does the tick. And if it was an image, I could replace the image. I can do a data transform when it renders and have it replace the image with a different image. All of that can be done really easily. Then the add is just simply take it, I check if it's a valid value. I'm adding to that collection. I create a new model called task. I give it the properties, and then I clear the field, and that's it. That's a simple to-do app. Now, obviously, there's no state here. It's not saving any of this anywhere. Now, with REST, I can configure a remote API and save that there. But equally, now this is where it gets fun. I can do something like, because we're using Backbone. Whoops. I told you this would be interesting. I can do collections, tasks. We start getting lots of autocomplete coming up. I can do an on-change trigger, on-change event handler. So whenever that collection changes, and then we can say, right, TI app properties. If I can spell, set object, tasks, hello collections tasks to JSON. And that, whenever that list changes, whenever I tick a box, it's going to save that straight to an object variable within the properties collection locally on the device with Titanium. And again, equally, I can say, okay, now we've done that, I could have a bit of code that says if ti.appRoperties, if I can remember my variables, no, that's the wrong one. The method has property. Try that instead. Tasks. And then we can do alloy.globals.resty, create collection, tasks, and then call in get object, she spelt wrong, tasks. I'm not going to run this, but it should work. So if I get rid of that top block of code now, then basically if there's a property called tasks, it's going to load in that collection. And obviously, if there wasn't, I'd probably need to create an empty collection or create a default collection. But essentially now I've got a to-do app that I can add tasks, they're saved locally, they have persistence, I can tick them on and off and everything gets saved. And adding delete is just adding another button, deleting a model, it deletes it from the list. It's just really, really simple. Let's see if this comes back. Yes. That was my backup video, which I don't need. So let me jump past that. That's it. That's Titanium. That's got time for any questions or? Yes.
So, what about debugging? Is it possible to live debug the app as it?
Yeah, if you use. Yeah, if there's a question about debugging, so live debugging. If you use the Accelerator IDE, there's a debugger in there and you can step through code, do breakpoints and everything else. There's also some third-party ones that have been done that will work within web developer consoles that can hook into Titanium and run within Chrome.
I have one more question.
Yep.
What about memory management?
Yeah.
What's your experience with the memory footprint that Titanium generates?
Well, yeah, and there's a runtime and there's an element there. I mean, typically, an iOS app is a few megabytes. If it was a Hello World app, I haven't checked the size of this one, but it'll be a few megabytes in size, and Android will be maybe the same, a little bit more. Memory-wise, I've never had a problem in terms of running the apps. The biggest problem with memory is optimizing memory within the app code to make sure that you're clearing up properly, garbage collection, because iOS is pretty good at it, and you can run through it. You can run an app through instruments and see what's happening when you open a new window. You can see all the proxy elements that get created on the other side of the bridge, plus the JS elements, and you can see as you close, as things start to reduce or go into the garbage collector, and it's fine. But equally, you can end up with situations where you open a sub window, you go back, you open a sub window, and those numbers are not going down as much as they should be. And typically that will happen because there'll be event listeners that people have added in that window that have got hooks into those local controls. And by not removing those event listeners when you exit that window, you've basically kept those controls open, which means you've kept the parents open, and that means you've kept the window open. And so you can very quickly. iOS is very forgiving though. It will do what it can, and then it will get to a point where the app will crash. but it will be a while. Whereas Android is not forgiving. So you launch your app in Android. I've seen apps where you launch them in iOS, they seem fine, they don't understand what the problem is. They launch it in Android and it crashes on startup, or it crashes after they open a window, and they're like, "Why is this happening?" Because Android just doesn't like that stuff, So I typically will run stuff through instruments on iOS to make sure everything's being cleaned up, and I do that from the start and periodically, because it's really easy at the start to go, everything's fine, and then I'll just add a load more functionality, and then that's when you add that killer control or killer event handler that then completely kills your app. So it's JavaScript. There's loads of ways to do JavaScript. There's loads of ways to have global objects and pollute the global scope and have global events that you don't clean up properly. So you do have to be careful with it. And more times than I'd like to see, you end up with people with issues, and it's usually that sort of stuff. They haven't put var in front of a variable, created a global variable, then later they've done something else, and that one little mistake has caused an app to blow up. Okay. Anything?
More questions? Okay.
Cool. Thank you very much.
Thanks.
Thank you.
Nice. Maybe you have to ship it.
Oh, okay, cool. Yeah.